So I'm just going to assume you remember everything that Arthur said. I'm going to move on from there. Or I mean, I'm going to assume that in some measure. Try not to be overly repetitive. So this is joint work with Arthur and with Jeff Dunbar in my department at Simon Fraser University. And this preliminary results, please do not cite, is sort of true. I mean, it doesn't mean it's utter garbage. It just means, you know, it's early. The tables that I'll eventually get to are like 2 weeks old. So, you know, it's that kind of thing. I'm going to talk about just a couple of things. Arthur alluded to 3 types of identification strategies for getting resource shares in collective household models, and I'm going to talk about those in just a little bit of detail today so that you can kind of get a feel for how they work. And I'm going to bring them to the data with a new investigation of, for us, old data. This is work again with data from Malawi, and the object of interest today is going to be trying to figure out how take-up of credit and of microcredit in particular affects children's resources in households. So there's a lot of microcredit around, and it's growing pretty fast. There are a lot of users. It's relatively new. So there were kind of the worldwide count of women's microcredit has gone from like 10 million to 100 million over the last decade. So it's becoming at least widespread. And there's a lot of debate over kind of whether it's good or bad. One of the initial targets was to make women better off by relaxing liquidity constraints, but also via just empowerment, you know, giving more choices. You know, it can affect well-being through the budget of the household. It can affect well-being through the within-household distribution of that budget. And it can also affect well-being through a completely different channel that I'm not really going to talk about today, and that's just through a sense of choice and agency in Sen's sense of freedom. One of the problems in this literature that I'm going to be able to take up a little bit is that if you just compare households who have microcredit or credit to households who don't, you're going to be misled because credit take-up is probably endogenous. And there's lots of work on trying to find instruments that are okay, and then there's other work that focuses on experimental designs where you just give up on instruments and instead just say, well, we'll either conduct an experiment or we'll find a natural experiment. And these studies typically find sort of smallish effects on household consumption and not much effect on specific categories of household consumption. And they typically, I mean, with just a couple of exceptions, have very little to say about the within-household distribution of consumption. And that last thing is what we're going to focus on today. And we're going to bring some instruments to the table so that it's just sort of, it's not obviously terrible and might have something real to say. Malawi actually has had some work on credit in that environment, and that work suggested that it does actually expand the household, that take-up of credit or microcredit expands the household budget, presumably via the relaxation of liquidity constraints. And where's my timer, actually? Oh, yeah. Oh, I got tons of time. So we're going to investigate, in particular, the question of whether having microcredit affects children's resources in households. And these data are extremely rich. I'm going to talk about them in a little while, but you know, when you're working with third world data, you're in an environment where if you pay households like $2, you can have a day of their time to learn about all the stuff they do. So it's really different from the kind of data that I'm used to working with, and pretty cool in that way. Yeah, okay. So the context in which we're going to be working is a collective household context. Heard some about that yesterday. Collective household models are models in which individuals, not households, have utilities, and individuals live in households. And essentially the way you think about the household is that it's an economic environment I think of them as machines that make budget constraints that are faced by people. And the prices or the budgets that individual people within the households have may or may not be observed. We're going to be in an efficient household environment, so we're going to assume that households reach the Pareto frontier. If we knew the budget constraints that were faced by the individuals that were in these households, then we could construct what Arthur called indifference scales, which are basically straight consumer surplus exercises. You take a fixed set of indifference curves and you say, well, this is the budget constraint they'd have in the household. This is what they'd have if they were, am I doing it the right direction? Sorry, I'll do it your way. That's the one in the household, that's the one if they're alone. You can just map out the indifference curves over the two constraints, holding the indifference curves constant, and you can construct consumer surplus. So much of the problem here is that we don't observe either the within-household shadow budget or the within-household shadow price constraint. One of the key elements, whenever you're trying to figure out how to characterize the within-household constraint, one of the things you're going to want to know is the shadow budget that people get to spend inside the household. And that shadow budget is related to the Pareto weight that the household would get. I'm going to say what all the letters are in a little bit, but basically, if you're getting to the frontier, you can think of the household's problem as a weighted average of the two or more utility functions in the household, where the weights depend on prices, the budget of the household, and other information, which I call D for distribution factors. Those weights map into an object called a resource share, which is the share of the total household budget that a person has. So that resource share is the object that I'm going to talk about how to identify. When you're in a world in which the household is a machine that generates budget constraints that are faced by people, the characteristics of this budget constraint is kind of what matters. And one of those characteristics is the budget of each person. And I'm going to characterize that with this resource share, which is the fraction of the household budget that goes to each person. So each person's going to have a resource share. They're going to spend it on goods at these within-household prices that may be unobserved. And basically, a bigger resource share means more consumption. That's the thing that makes it a useful object to learn about. And so it's going to be useful for thinking about inequality, within-household inequality, or inequality at the level of the whole economy. For thinking about poverty, our older paper talks about using resource shares to measure poverty, and it makes a big difference when you measure poverty because this approach allows for within-household inequality, which means the standard poverty measures, with which you'd assume that households are defined as poor or not, can be replaced by a poverty measure in which you think about whether individuals are poor or not, and not all individuals in a household can be poor. Some could be poor and some could be non-poor. And in particular, in the Malawian data that we looked at, only about 65% of men were poor, but like 90% of women were poor. So this within-household inequality that you can illuminate by looking at resource shares can be
that's
big.
a result via the model?
Result via the model. Yeah. I mean, I'll speak to that in just a little bit. There are model-free ways to get at this information.
So are there? I mean, that'll be interesting too.
Yeah, and yeah, they're awesome. But okay, let's go there. Yeah. So how can you identify these resource shares? There's a long history of work that Arthur referred to as the C model, wherein you can identify the response of resource shares to things called distribution factors. Distribution factors are things that affect resource shares, but not preferences or shadow prices. So they're special variables and they only affect resource shares. And so if you observe a change in behavior as those distribution factors change, you can pin it on the resource shares because you know that's the only channel. So you can back out the derivatives of the resource shares with respect to distribution factors, but in the C model, you cannot identify the level of the resource share itself. There's revealed preference-related work that shows that you can bound resource shares in that model. And there's a new paper by, oh, you know, it's just L3, hang on, Dirac, Scherche, and Vermeulen that approaches this model from a less model-y way. And they just say, well, look, if you just collect data on the individual, on the person level consumption of each good within the household, then you can kind of just add up all those goods. You don't need much model. You can just use arithmetic and get information on resource shares. Even in that world, you need to know the shadow prices at which to evaluate. So they get around that by saying, well, they're not shadow. We observe them. We're gonna claim we know them. Another model, which is the model,
and all of this is with public goods. I mean, that's always the distinction here.
In the C model, you've got pure public and pure private goods.
But I'm just saying, when you start observing the data, when there's an issue about what exactly you're observing with a public good, I guess. But anyway, I just wanted to clarify.
Yeah. So, but the model that I'm going to work with today is a model in which you have goods, is the BCL model, which is the second class of models that Arthur talked about. And there, instead of assuming that all goods are purely public or purely private, so that you know either the consumption level or the shadow price of the good, well, it's not a shadow price, you know either the consumption level or the price. In this model, you do not know the shadow prices of the good, and you assume that all goods are, you know, somewhat shareable, somewhere between fully shareable and not shareable at all, and you use price variation to identify the shadow price vector in the household. And you use the fact that you know preferences, or assume that you know what preferences look like, to identify the shadow budgets, which gives you the resource shares. So the BCL model, with known preferences and with observed price variation, is a model in which
you mean known functional forms, or known with up to parameters, so really known in the sense that, I just wonder what you mean by known preferences.
This is a non-parametric identification result. It means that if you have the non-parametric function for demand functions for each person over prices and budgets, you take that as known, then you can cram it into a model of the household and back out the shadow budgets that each person faces in the household. It's quite an assumption. We're not going to use it. We're going to relax it.
Essentially, it means that you're assuming that you can observe those preferences on singles. That's the assumption.
Okay.
Yeah.
Totally going to relax that thing of knowingness. But we are going to use that model. So there are three results that I'm going to talk about today, identification results in the context of the BCL model, and they're going to relax the amount that you need to know. So I'm gonna, the ones I'm going to talk about today are our AER paper that's forthcoming, and a new one. And basically, if the BCL model holds and resource shares are independent of household expenditure, I'm going to say a little bit about the strength of that assumption, because it's essentially, it's the key identifying assumption. If those two things are true, and I'm going to tell you what the BCL model is in a little moment, then if you add a restriction on preferences and an assignable good is a good for which I can observe the amount consumed by each person. I only need one such good for each person. It could be a good like clothing. Indeed, it is clothing in the data that we're going to look like. So we're going to have men's clothing, women's clothing, and children's clothing in these data. But we're not going to have like men's food, women's food, and children's food, so we don't have sufficient data to do the adding up version. We just have some data like that. If you give me a restriction on preferences and an assignable good, then levels of resource shares are semi-parametrically identified, and I'm going to say what that means in a few minutes. for adults and children without price variation. So the key things that we don't need compared to BCL is we don't need price variation. We don't need to observe the variation in prices across individuals. We don't need to observe preferences for anyone. And what that means is that we don't need the restriction that, for example, a man living in a household with a wife and children has the same preferences as a man living alone or a woman or a child. That's the, don't need the prices, don't need, yeah, I think that's, those are the don't needs.
Just a little bit on the interpretation of children's preferences in this context. I assume we're talking about relatively young children. We're not necessarily talking about adolescents who are players in a bargaining game of some sort.
Everybody, so in our model, every person in the household has a utility function.
Yeah,
so it's
that's what I want to push you on. That's what
it's this,
what I want to push you on.
Right?
Yeah.
We're going to extend this maximization to cover more people. So it's a maximization of person 1, person 2, and person 3's utility.
That's just the issue I want to push you on. That is, since we really don't think these are necessarily the child's own preferences, that there's a sense in which they're the preferences of the parents. So let's suppose that each parent has what we will call a utility function or a welfare function for the child. Think of this as one child. There's no problem if we assume that mom's welfare function for the child is the same as dad's welfare function for the child.
If they disagree over, so I think the model that I actually think is the way to think about this is that the child has a utility function and someone is optimizing it for them. But if the child actually has like 2 versions of utility function, one in the head of one parent and one in the head of the other parent, then really you're going to have 4 arguments to this. You're going to have mother's utility, father's utility, kids' mother's idea, and kids' father's idea. And that will make the optimization more complicated, and it will, roughly speaking, tell you that you should pretend there are 2 children even though there are 1. It's still practicable. You can still estimate the model, but it weirds it up some.
Okay, thank you.
This identification that I will describe in a little bit does not require a distribution factor. So it sits firmly in the BCL style of getting the levels of the resource share without the use of a distribution factor. A distribution factor, you recall, is this special thing that only affects resource shares and does not affect shadow prices in the household or preferences of anybody. So it's very special. But there is a kind of a large literature on, oh, well, there are distribution factors and they're so special and we love them. And so we started thinking about, well, how could you use a distribution factor to achieve identification in this context? And we came up with a new identification result, and that says that with a distribution factor, you can get rid of the preference restriction. So, and the way I think about this is that a distribution factor is a preference restriction. It's that there's this variable that doesn't show up in preferences. And so, I mean, in that way of talking about it, it's totally not surprising, but still new. Okay, so.
Could you just go back 1 second on the previous slide? So everything's going to be maintained on this key ID that resource shares are independent of household expenditure.
Yeah.
That seems like a strong.
Yeah, it's totally strong. And how could you believe this thing?
No, I'm just asking exactly what are the necessary. Do you have a good characterization of the class of preferences?
We have. Okay, so in the appendix to our AAR paper, we have a class of household optimizations, basically that utility maximization on the second slide. We have a class of those things that satisfies this, and they're basically up to Pigel complexity utility functions and up to S-Gini complexity social welfare functions. So it's not everything, but it's not nothing either.
May I add something on this? Take the extreme case in which all commodities are private, which is not very interesting, but they take that as a benchmark. Then you take any sharing rule, the allocation will be efficient, and you can take a sharing rule which is independent, which is just what each person gets is proportional to total expenditures, and this is fully compatible with us. And then you can put any utility you want. You will always get efficiency. So I don't think it's a strong summary. I mean, it's an empirically testable.
Yeah, that's true, but it then will result in a social welfare function for the household that depends on the utility functions of the individuals. So if somebody's preferences changed, you'd also have to change the social welfare function, or you'd have to change the Pareto weight function.
I mean, the value of the parameterization of the social welfare function.
I'm just going to roll over you guys, because that's not what I'm going to talk about. So there exists a class of utility functions and social welfare functions that'll give it, but you might think it's too restrictive, so there are two ways to bring this to the data. Arthur already showed you one way. That graph that he showed you with too many blue and non-blue marks, in which the resource shares kind of like were within this wide band, and the wide band included flat. That's one way to get at this. And another way to get at this is via stated preference. So I have a paper in which that stated preference question is taken head on. There's a survey, an Italian survey, in which people are asked, of the monthly expenditure of your household, what do you spend in percent for your children? And here's the answer. Here's monthly expenditure in euros. Here's the stated, what do you spend on your children? And look at flattish. Okay, so this is one child, it's kind of flattish. Two children, it's kind of flattish. Three, there's this, and you're thinking it's not flat, but these are the 90% confidence, pointwise confidence intervals, so it's flattish. So the data just don't scream that resource shares very much with household expenditure. And so identification theorems like ours that depend on this restriction could be okay. Okay, so now I'm going to tell you the theorems, and then I'm going to jump to the data. Hopefully 11 minutes each. So there's going to be three people, MFC, mother, father, children. The children are going to be a lump for what I'm talking about, but if you have an assignable good for each child, you can unlump them. So, so the lumping of children is not required. Y is household total expenditure. D are these distribution factors, which are going to come in a little when I show you the distribution factor identification. Sorry, identification with distribution factors. Each person is going to get a resource share N super J and a shadow budget then of NJY. That should be a Y, I apologize. NJ, the resource share, can depend on Y and D. It can depend on these distribution factors, also on the household budget, and they sum to 1. The household's angle curve, or budget share function for an assignable good, for person J is going to be capital WJ, and the only things in the model so far are the budget of the household and these distribution factors, and this thing's observed. But it's going to depend on kind of a what would an individual do if faced with some kind of budget constraint. A person's shadow angle curve, or budget share function, is little wj, which is a function of y, the household budget, and it describes what that person would do if they were living alone, facing a shadow price vector and budget that exists for them in the household. And it is not observed. It's not even a thing, I mean, because I got children in the model, it's not even a thing that could be observed. It's just, it's a what if, it's a thought experiment. And you're going to have to hold in your head that this is evaluated not at the market price vector, but at the shadow price vector inside the household. This I've already said. Given the BCL model, the observed, now this is just their result for an assignable good, and it's very much simpler than their result for any good that's not assignable. But for an assignable good, the budget share function for the household for person J's assignable good is just their resource share times what that person would do if living alone, facing the shadow price vector, and having their resource share times the household budget. So having their budget within the household. So you can kind of see how BCL gets identification. They say that this function Wj is observed. So I got all these. All I've got that's not observed is this. So there's enough information here to pick up these guys. So you might say to yourself, that's kind of a cheap trick. I've got so much unobserved. I've got 2 unobserved functions on the right-hand side. I pretend 1 observed, I'm good. So this thing is not observed if the lowercase wj's are not observed. And I just want to say exactly why. It's because there are too many subscripted functions here. There's 3 people in the household, so there are 3 of these functions, and then there are 2 of these functions because they sum to 1. There's only 2 free functions. So there's 5 functions. I only got these 3 things. So there's kind of too many subscripts, although I'm going to show you why you shouldn't be too
So this
worried
would
about
include
that.
child goods as well, is that right?
Sorry?
This would include child goods as well, the WJ?
The WJ is there's a children's assignable good, like children's clothing.
No, I understand, but you were saying you could get these identifications off of people living alone. So we look at kids in orphanages, or?
No, yes, you could, but due to orphan non-response, that's not going to work.
No, seriously. I mean,
No, seriously, I'm going to have an answer, and it's going to be awesome. Okay, so now I want to identify without the distribution factors, and I'm just going to do that counting stuff again. So I'm going to take these.
The notation. Capital W is?
Capital W is observed. It's the household level budget share, share of total expenditure going to assignable good J. Person J's assignable good. So W? Capital W man is the men's clothing equation for the household, and it's observable. But lowercase w man is what the man would do if they were living alone, facing the shadow price vector of the household and having a budget n times y.
Krishna, for the sake of clarity, you might want to add "and if his preferences when living alone were the same as his preferences when living as a couple," because you're not assuming that.
That's right.
In other words, you're not saying this is something that you can observe on single.
Yes, we're not. I'm not going to ask to observe it. Yeah. So in the thought experiment, you want
So I was going to ask that question: how you would actually think if there were these goods produced that, like love and hate and things that we're talking about. Yeah.
Okay. Well, just bear with me and see if you don't like it in about a minute.
So
okay.
The little nj is
the resource share of person J in the household. Okay. So, but I'm going to kill its dependence on y, because that's an identifying restriction that I use. And I'm not going to need any distribution factors in this identification, so I'm going to drop that. So n is just n with no arguments.
So killing the dependence on y is homotheticity plus something about bargaining, right? I'm just trying to understand what it means not to depend on
It's definitely not homotheticity. You do not need homothetic preferences.
Aren't you saying the shares are independent of the income?
The resource shares, that's the optimal share of household expenditure that goes to person J, doesn't depend on the household budget.
But then you also say the single guy's thing doesn't depend on.
Nope, that's not true.
Oh, you're going to leave it in?
Yeah.
It's his income. So the single guy has an income.
There's no restriction on a person's preferences.
Ah, okay.
Okay. So I got just a number. There's no arguments now to the resource share, and so when I do that substitution, the d's drop out. So all I've got is dependence on the household budget. So this is a straight angled curve with nothing in it, and this is the men's unobserved budget share function at shadow prices, and then the argument to that is, well, the budget that they actually have in the household. So there's still too many subscripts because I got one J superscripted thing over here and 2 of them over here. So I got too much. But if people had identical preferences, you could immediately see how you get identification. If people had identical preferences, then there'd be one function here, and then there'd be 2 numbers here that we had to extract from these 3 functions. So the counting exercise would tell you that if you had identical preferences across the 3 people in the household, you'd have enough information to identify. But identical preferences is a lot to ask. So what we show in our paper is that these preferences don't need to be identical. They just need to be similar. With a similarity, and I'm going to talk briefly about what kind of similarity in preferences you need, but the counting exercise with similarity is the same as the counting exercise with identicalness. And it's semi-parametrically identified in the sense that I need a parametric similarity across the people in the WJ functions. But other than that, the WJ functions can look like anything. And it's easy to see in a linear case what similarity implies. So I'm gonna go to that in just a second. We're going to be able to pick up resource shares for children as well, and that came, you can see that from the counting exercise, because I did it with an example with 3 people. And I never need to observe these people in any other kind of, I never need singles preferences. I just need the thought experiment of there exist singles preferences. I need that to exist. But I never need to observe them. Okay, so I'm going to give you the intuition in about a minute. But before that, I'm going to talk about identification with a distribution factor. So I'm going to bring back the Ds. That is the distribution factors, the things that only affect resource shares and do not affect preferences. I'm going to keep the resource shares independent of total expenditure Y. And so, dang it, I'm afraid that's supposed to be a D in there. Sorry.
Yeah, you should have a D on the right-hand side somewhere, right?
Yeah, so wait, I have a little pointy thing. So that's a D, and that's a D. So the budget share function for the household it's got the same structure. The resource shares now depend on distribution factors D. I'll just make a little D symbol, D, trust me, D. Just to show you, give you a little intuition as to how identification works, just let D, I apologize again, let the distribution factors be discrete with values indexed by T. So now I've got superscript J for the person and a subscript T for the various values that the distribution factor can take, and likewise in there. And since the function W, the preferences of person J, does not vary with T, and since the resource shares sum to 1 for each T, you get a signal on this function W for every T that you observe. And so if the distribution factors and the budgets that you're moving across with these distribution factors have enough support points, then the resource shares and these functions WJ are identified from behavior. That too is going to be easier to see in a linear case. So unlike the previous where I had to have a preference restriction like a similarity across preferences, here I don't need any preference restriction, but I do need that the distribution factors affect the resource shares and don't affect preferences.
Krishna.
Yeah.
So I saw the data that you showed that the fraction, the share is not changing with income. But I'm thinking that as this is true for Malawi, but you have a very limited range of income. So I'm thinking, if, for example, you start having a lot.
Actually, that scatter plot I showed you was from Italian data. So Italians have some rich people. But you're absolutely right that Malawi is pretty darn poor and pretty compressed into the poorness.
Isn't it the case that, for example, as income increases, that parents are going to spend more on education and health of the children? In which case, the share of the share that children get increase with income? Could you now switch and instead of not allowing for the resource share not to depend on income, could you now have the distribution factor, the weaker preference restriction that you had before, and at the same time allow for the income to directly affect the resource share?
We haven't figured out how to do that. Roughly speaking, you're going to have to give me another restriction to replace that restriction. And yeah.
But, one result we do have is that you only need to have the resource share not depend on income at low levels of income.
Oh, okay. So it's not everywhere.
So it doesn't have to be true everywhere.
Okay.
So now this is a capital W. It shouldn't be. I apologize for that. Now I want to consider an environment where each individual, that is the lowercase w's, each of those lowercase w functions is linear. So these are, each individual has linear angle curves or almost ideal utility functions. And I'm going to introduce another subscript, S, for the household size, in this case the number of children. You'll see why that's necessary in a moment. And that number of children is going to go from 1 to 4 because that happens to be what it does in our data. This is a lowercase js. It's going to have an intercept that depends on the person and the household size, and a slope that depends on the person and the household size. And now I'm going to just cram that into the structural model. So here's the budget share for the household. It's the person's resource share in the household size S, and it could depend on distribution factors, and then multiplied by, well, that person has an intercept, that person has a slope with respect to, well, total expenditure, or log total expenditure, but log total expenditure times their resource share in that household size. So in this case, the household angle curves are also linear in the log of expenditure. And there's a little modification for kid shares. I'm going to ignore it. OK, so I give you I can still do it. Don't worry. I'm going to give you the spirit of identification with a preference restriction. So I'm going to take that same equation that I had a minute ago, where the resource share multiplied this linear thing. Basically, there's too many things with J and S indices. We need restrictions on preferences in this environment. So first kind of preference, impose a similarity across the people. The people are indexed J, so I impose something similar across mother, father, and child. I'm going to impose that the slopes are similar. That the slopes are similar is related to shape invariance across these people, or equivalent scale exactness, if you prefer. It's a preference restriction that's been imposed a jillion times in the literature on consumer demand. And one of the reasons it's imposed is because it's feasible. It's a nice way of compressing complexity in demand system estimation, and because it relates to understandable restrictions on utility functions. So if I were to do that, then these slopey things drop their J subscript. OK, so now for a given S, there are 3 slopes that I can get from the data. The slope of the household angle curve for men's clothing, women's clothing, and children's clothing. That's 3 slopes with respect to log y. And then there are 3 unknowns. One B, one common slope shared by all the people, and 2 of these resource shares. So this is a parametric example of how the semi-parametric identification works, and that's by imposing a similarity across the people. You could also impose similarity across the types of economic environments that these people are in, and those economic environments are household with 1 kid, 2 kid, 3 kid, 4 kid. I'm going to say, well, let's say that each person does have their own slope, but that slope is the same whether they're in a household with 1 child, 2 child, 3 child, or 4 children. So that is to say, preferences don't change that much for a person across these 4 economic environments that are characterized by these 4 household sizes. So in this case...
So do you characterize that more in terms of the primitives about complementarity?
It's a restriction on how prices enter utility functions.
Right,
actually.
but that's also another direct restriction on the direct preferences too, right?
Yes,
yeah,
it's a restriction on individual utility functions. It seems to rule out a lot of
kind of complementarity that might be going on in the household, right? I mean, the father's utility for, walking in the park may be fundamentally different, and the budget share it's spent, just depending on child. I'm just wondering, I understand the algebra, I think, pretty well, but I think what I don't understand is economics underlying.
The economics of this restriction are that the price differences across household types can be absorbed into an income deflator. And so we would normally associate that with homogeneity of preferences. But in this case, because it's only for four price vectors, you could take those as given and say for those 4 price vectors characterizing these 4 constraints. So you see where I'm going. Yeah. So actually, for that reason, I find this one less satisfying than this one. Unfortunately, the data are going to say the opposite, which really annoys me because he found this one more compelling than this one. But anyway, no, I'm going to say no. OK, let me just do the counting, and then I'm going to do the last thing, and then I'm going to show you some data. I got to say no, I'm sorry. We can come back to you. I only got 4 minutes, 16 seconds. So with 3 household sizes here, I get 9 slopes over here. But with 3 household sizes, there are only 9 unknowns because I got rid of the S subscript on the B. So I got 3 slopes of the latent functions to identify and 6 of these resource shares. So lastly, let me give you with identification with distribution factors. Here, I'm going to bring back the D's, and I'm going to bring back that indexing with T, and write it out like that. And it looks like you've got a lot of indexes. Again, you got, a JST and a JST. But in fact, there are not too many indexes here. And the reason is that these, for each ST, these things sum to 1. So for every T I observe, I'm going to get a new piece of information that I can use over here. So for a given household size S, if I have 3 support points T, then again, I got 9 slopes over here and 9 unknowns. So, OK, so now I'm just going to go right to the data. Let's see.
That's not quite an identification theorem, but.
No, the identification theorem is an actual theorem. That's the way I think about the, yeah. But for theoreming, we're with you. There's like an appendix. OK. Malawi's poor. They have microcredit. Poor again. OK. I apologize. Endogeneity corrections for the microcredit. Cool instruments. OK.
So what's the cool instruments?
The cool instruments are the cool instruments are for the coffee break, but they're cool. OK. OK, so I just these are 3 types of identification: the similar across people, similar across types, and identification with distribution factors. In the model that we showed you, this is strictly more general than either of these because this doesn't impose anything about the linear demand curves of each individual. And so given this structure, we can actually test both of these. And well, this one, similar across the types of households that people are in, is not rejected. And this one is rejected. So yeah, I totally sympathize. Price restriction, weird. Restriction across people, a little easier to swallow, but the data aren't with us on this. OK, so now I'm just going to give you a bigger table. And these numbers are really just showing you that you can actually identify these resource shares in a way that is useful. And by useful, I mean the standard error is little. So standard error of 0.04, 0.05 actually means that these objects are you can kind of trap them in useful ranges that actually say something. I'm not going to say anything more about that because it's very similar to what's in the other paper. This is the credit effects, and I'm just going to focus on the what's going on in the last column. These are dummies for whether or not you have a loan from like the grocer. This is the dominant form of borrowing in these villages. About 10% of people have a loan 10% of households have a loan from the grocer. About 3% of households have a microcredit loan, and microcredit loan is almost exclusively aimed at women. These are women's microcredit agencies operating in these villages. And then this is the size of the loan, normed by the median size, and this is the size of the microcredit loan. So these are the distribution factors. They're excluded from preferences. They're in the resource shares, and here are coefficients. These are measured in like resource share points. So the main two things that jump out of this, that's hard for them to jump out, are that microcredit diverts resources from women, that's a minus, to children. And it's an enormous magnitude. It's too enormous, actually. But this kind of big magnitude diversion from women to children is something you see in like any of the 200 specifications that I ran over the last 2 weeks. Sometimes it's not as sillily big as this, but that's definitely there. The second thing you see is that when the microcredit loan is a big loan, the size of this diversion is smaller. That's what this plus coefficient to women means when it's on the size of the loan. So I will stop.
We have time for one question.
You had something back there.
But you're not supposed to ask a question.
So the question was, in your first assumption about the angle curves, where you assume they're identical across individuals in the household, isn't this equivalent to exact aggregation, which means that the collective model is identical to the unitary model?
Yes, but I do not use identicalness across people. I use similarity across
but
people.
the slope is enough to make the collective model.
So this, oh, I see. Is this collective? No, it isn't. So this is exact aggregation, which is the aggregation where you need a piece of information about distribution in there. You're probably thinking about quasi-homothetic preferences, which are linear in y, not in log y.
Thank you very much.